Hello and good morning. Another beautiful day in southern Utah. Welcome to Geological Hikes by Thomas. I'm Thomas Eckhart, your tour guide. Just a quick disclaimer. I'm a scientist. I'm not a trained geologist. I've been interested in geology, however, for about 7 decades now, so I'll try to keep it very simple. I try to stay away from scientific jargon so everybody can understand what it's all about. I'm doing this series because I want to highlight not only the beautiful landscape in southwestern Utah, but also the amazing geological features here, which are largely unknown. And today we'll see one of those features here. I'm up at Brian Head, a prominent peak in southwestern Utah. You can see the Brian Head behind me now, or above my head. That's what we're going to be talking about. Today's topic is volcanic ashes from supervolcanoes. The talk will be in two parts. The first part will deal with some ashes, volcanic ashes, how they're formed, what kind there are. The second part, we're using the knowledge about those ash layers and the position of those ash layers to solve a scientific riddle. Well, it has been solved before, but we'll solve it again. A catastrophe that happened here about 20 million years ago. Let's talk ashes. Gray layer with the little sheep running on it, that's volcanic ash. It's volcanic ash that was ejected by the eruption, thrown high up in the air, drops down, and was deposited here. This is what's called an aerial ash deposit. This particular deposit was deposited in a lake or streams, was deposited underwater. It got transformed by the water and weathering and turned into a clay called bentonite, or more popular, blue clay. Blue clay has a nasty property of swelling. When wet, it gets very slippery. That's a very important property we need to keep in mind. This ash layer was erupted from a cone volcano, not a supervolcano, and it was deposited here about 36 million years ago. Before we drive up to the top of Brian Head, let's look at the rock formation up on the top from down here. They're very different from the gray ashes in front, but they're also ash deposits from supervolcano eruptions. Ash flows, ash flowing within hot gas along the contours of the land, spreading with lightning speed up to 700 kilometers an hour and reaching the site here about 60 miles away from the eruption within about 5-7 minutes. Well, we made it up to Brian Head. I see a cairn here, I see a little trail. Climbing down from Brian Head, we reached a point that allows us great view on the rock face. We see them from below. In the center we notice a prominent rock band. It looks like basalt, but it's not. It's tightly welded volcanic tuff deposited here by an ash flow. The ash flow was very thick. At the bottom the ash was compressed and was actually melting. Above this rock layer with the talus, and on top there is moderate welded tuff. Both layers are part of the Leech Canyon formation, deposited here by a supervolcanic explosion, ash flow, about 24 million years ago. Below this tightly welded tough rock band, there is some reddish rock there. This turns out to be not a ash flow deposit, but a aerial ash deposit. So supervolcanoes can have both at the same time. Regular cone volcanoes like Mount St. Helens have eruption with both aerial ash flows and pyroclastic ash flows, hot ash flows along the surface of the volcano. Below this reddish layer were some black outcroppings. That's the isome formation. The isome formation was a very hot ash flow, about 200 centigrades hotter than usual. It's very tightly welded and it's easily recognized throughout the region. So let's have a closer look at the tightly welded layers here. It looks like basalt, but it's not. Comes through here. I have some nice specimens here. Dark, grainy, lot of glittering in it, so it's recrystallized some larger crystals. Pieces of pumice traveled with the ash cloud and were embedded into the ash cloud. Here we're nice and round. We are now at the level of the Isome Formation, deposited here around 26 million years ago. It's black outcroppings, some red outcroppings, some red stones here. This looks very different. This is a nice piece, banded. You see openings in the rock, all originally round openings and compressed. Isn't that a gorgeous view? It's only a few minutes later, but clouds are moving in quickly. We're going to have some rain pretty soon. Well, I stopped off at the Sydney Peak trailhead. It's quite busy here, and I'm picking up the Sydney Peak trail for a little while. From the first session, let's recapitulate. I was looking at the nice scenery here. We've seen 3 ash layers. On the bottom, the blue clay. Let's just remember, blue clay, slippery, laid down about 36 million years ago. Then you had the Isome ash flow, formed a tightly welded tuff, and then you had the Leech Canyon formation. And here we have a good opportunity to see the Tushar Mountains again much more clearly than last time. Mount Baldy to the left and Mount Belknap to the right. Mount Belknap plays also a role in our riddle we're trying to solve today. All the layers on top here are Leech Canyon formation. The top layer, it's less welded, falls easily apart, but let's have a look at it. Some chunks here. As I mentioned before, or maybe not, this formation has some nice inclusions. We see an inclusion here. We see there's another one down here. It also has some pumice pieces. Yeah, this is a piece of pumice, usually void. You see it over here. You can see it over here. This is a nice piece. I like this. It's a nice piece. And you have pumice just close by. Can't get any better. Well, this reddish rock, that's part of the wall of the magma chamber that was ripped up in the explosion of the supervolcano. So let's go along, be careful. We're treading solid ground. And as we continue on, the landscape changes. No more Leech Canyon formation. It's a dark rock. Looks a little bit like basalt. This entire knoll is this rock. So what is it? Well, let's bang up a rock. Okay. There are a lot of glittery crystals in it. That's a tightly welded tuff, melted, and when crystals formed when it cooled down. Beautiful transition from the Leech Canyon formation to a black dark formation. The rocks look like basalt, but we know it's not basalt. It's a tightly welded tuff. And surprise, surprise, this is the Isome formation. The Isome formation was deposited 26 million years ago, and the Leech Canyon formation below the Isome formation here 24 million years ago. We've seen that in Bryanet. 2 processes which can give this result. One process is tectonics, where layers are shoved over each other by tectonic forces. The other possibility is landslides. Here I picked up a piece of the Isome formation. It's interesting because it's layered, has kind of flow structures. Again, indicative that this rock formed from ash was compressed and liquefied. That's a vitrifier here. Here in the center we have the top layer of the Leech Canyon formation. As we swing around, the rocks gets very different. We have a lot of rocks in the rock. Some are cornered, some are a little rounded. That's what's called the breccia. That gives another clue what could be happening here. Some nice samples here. On the other side here is single blocks. Look at this guy, he has a big boulder. And this looks like, could be ice formation as well, blackish inclusion. Has some red rocks. Top, oh, this just lies on top. No, it's solid. This could be a part of the mantle of the magma chamber. And there is one way a breccia can be formed, and that's in a landslide. Well, let's pretend you're up in Brian Head or whereabouts, about 26 million years ago. Enjoying the sun, looking at the clouds with concern. Yeah, we might have lightning again. You hear a big bang in the back. Turn around and see the lovely landscape being engulfed and covered with a 3,000–4,000 feet high wall of hot ash. And it's coming here, settling down here. Not a good afternoon if you're here, but nobody is here. Are you ready to solve the riddle? I know I am. We had a blue clay, slippery. We had a reversal of order of deposition, apparently. Older ash layer on top of a younger ash layer. That can happen with tectonic movements or with landslides. A little further down we had a breccia, most frequently associated with landslides or rock slides. So my conclusion is it's a landslide. And yes, I'm right. Well, I read up before it. If you're into superlatives, this is the largest landslide on Earth. As a matter of fact, about 20 to 22 million years ago, about 1,600 square miles or 4,000 square kilometer chunk of land the size of Rhode Island slid down from here about 25 miles or more. This entire plateau, that's one gigantic landslide. It's called the Markagant landslide. How did this landslide occur? Let me show you a schematic of the landslide. It's from the Biek publication. Up here you have the Mount Belknap area. The lava dome is growing inside. You have the gray layers that corresponds to our blue clay. You have the ash layers, and then sliding down here. One last swipe before we leave the area. Black clouds are coming in. I hear some thundering, but with the shades and the colors, it's just too beautiful to pass up. Well, we're coming to the end of this segment here. Before we leave, we'll solve another riddle. I'm Swiss, and my accent is Swiss, just in case you have been guessing for a half an hour or so. Thanks for sticking around. Take care till next time.